Alright, for our second video we're going to be doing factoring by grouping, this time with the additive inverse, and I'll show you what that means through our examples here. Now as we're working, one thing to remember or kind of review from before is this commutative property. And it says if we have A plus B in this order, it means the same exact thing as switching them around, B plus A. Now that only works if it's addition between them. Now remember, if we have something like A minus B, that's the same as A plus negative B. So we can switch it to negative B plus A. Okay, the commutative property lets us switch things around like that as well. I'm going to leave that up on the side here for us to kind of review back to or look back at. If we look at our first example here, 2AB minus 12A plus 42 minus 7B. Like before, we're going to put these into groups. So we have a red group here and a blue group here. 2AB minus 12A is one of them, and positive 42 minus 7B. If we look at our first one in red, we have 2AB minus 12A. We can take out 2A from each of those. 12 is divisible by 2, 2 is divisible by 2, and we can take A out of both of them. When we do that, what's left over? B in this first term, because 2A times B is 2AB, and negative 6 in this second term, because 2A times negative 6 is negative 12A. Now let's look at our second group, this blue one. Positive 42 and negative 7B, we can take out positive 7 from each of those, because 7 times 6, positive 6 would be 42, and 7 times negative B would be negative 7B. Now, like before, our goal was to get this piece and this piece to be the exact same. And they're not quite the same in this one. Here we have B minus 6, here we have 6 minus B. So these are what's called additive inverses of each other, because in here the B is positive, the 6 is negative. Here it's the other way around, positive 6 and negative B. So how can we change this? How can we fix it so that we have the correct thing? Well, how about instead of taking out a positive 7, we'll take out a negative 7. If we take out negative 7 times what would be positive 42? Well, it'd have to be a negative 6. Negative 7 times what would be negative 7b? We need a positive b. So now things are starting to look a little bit closer. We have negative 6 and negative 6, positive b and positive b. And remember, from our commutative property over here, we can switch these two pieces around. We'll leave the positive b in the front, and we'll take this negative 6, move it to the back, positive b plus negative 6. Instead of saying plus negative 6, let's just call it minus 6. So b minus 6 is now our red term. And that does match our red term from over here, or our red factor. B minus 6 and B minus 6. So that's our new red piece, our new red factor in both cases here. And our blue piece, we have 2a and minus 7. So that factor, or that binomial, would be 2a minus 7. So this is now our factored form. We have two binomials being multiplied together. Again, if we were to FOIL this all out, it would become this original polynomial. So let's look at example C next. We'll put it into two groups. We have a minus 2ab and positive 8b minus 4, with a negative 4. So we have our two groups there, 4 terms in total on this polynomial, so we can factor it by grouping. If our first term is just a at most, the only thing we can take out is a, and luckily in this term we have an a, so we can take that out. A times what would be a? Well, just a positive 1. That's the best we can do. A times what would be negative 2ab? Well, it would be negative 2b. If we were to multiply this out, it would become this term, or this piece, binomial right here. Let's look at our red binomial then, our red group. 8b minus 4. Well, best we can take out of that is a positive 4. Positive 4 times what would be positive 8b? Well, that would be 2b. Positive 4 times what would be negative 4? And that would be negative 1. Now again, we have a positive 1 and a negative 2b. Over here we have a positive 2b and a negative 1. So how do we change that? Well, instead of taking out positive 4, let's take out negative 4 from each piece. Negative 4 times what would be positive 8b? We'd have to change this to a negative 2b. Negative 4 times what would be negative 4? We'd have to change this to a positive 1. Okay, so now our pieces are the same. We have negative 2b, positive 1, and positive 1. We just have to switch them around with our commutative property. This 1 comes out front. This negative 2b moves to the back. And instead of saying add negative 2b, we'll just say subtract 2b. So now our red pieces look exactly the same. 1 minus 2b in each case. And in one case we are multiplying it by a, in one case we're multiplying it by negative 4. Oops. So there's our red piece, the 1 minus 2b. In one case multiplying it by a, in one case multiplying it by negative 4. So this would be our factored form. These two binomials multiplied together, again, if you FOIL this out, will become this piece. Let's look at our last example, example B here. Now before, in our very first slide, we said always factor out the greatest common factor first, if you can. Let's take a look at all of these pieces. 6p, 4p squared, negative 36p, and 54. We cannot factor out any variables because this piece doesn't have any. But if we look at our coefficients, 6, 4, 36, and 54, we can factor out something from the coefficients. Instead of doing all the trees and figuring out what that would be, let's just kind of think intuitively about that. Each of these is an even number. So we can factor out a 2. If we factor out 2, this one would become 3p, and 3 is prime, so we know we can't make that one any smaller. This one would be negative 2p squared. Again, 2 is prime, so we can't make that one any smaller. So we know that 2 here is the biggest factor that we could have taken out of everything. So let's finish it out. If we took 2 out of each of these things, this one would be negative 18p, and this one would be positive 27. So the very first thing we did was take out this factor 2 from each of those 4 pieces. Now, this is when we can look at everything and say, all right, here is my first group, and here is my second group. And don't forget this one has a negative with it. We need to make sure that we leave this factor 2 on the outside of everything. So as we work, I'm going to leave that there. So we remember it's 2 times all of that. If we look at our first group here, 3p minus 2p squared. Can't take anything out of the coefficients, they're both prime, but I can take p out of each of them, the variable p. So p times what would be 3p? Well, that'd be 3. P times what would be negative 2p squared? That'd be negative 2p. So p times all of this would give us this group. Let's look at our blue group. We've got negative 18p plus 27. What can I take out of each of those? Well, 18 and 27 are both divisible by 9. We have a p here, but we don't have a p over here. So 9 is the biggest number we can take out. When we take out a 9, this piece becomes negative 2p. Remember, we had this negative along with it. 9 out of 27 leaves 3. Now notice I put the 2 on the outside of these black parentheses to say it's 2 times all of this amount. So now we've got negative 2, positive 3 and a negative 2p over here. We've got a negative 2p and a positive 3 over here. So just like before, all we have to do is move these around using our commutative property, switch them around that plus sign. Positive 3 minus 2p. I'm going to change this to, instead of adding a negative, we'll just say it's positive 3 minus 2p. Now those pieces match up. They are exactly the same. So we leave our factor of 2 there like it was before. 3p minus, or 3 minus 2p is our red piece, and p plus 9 is our blue piece. So this would be our new factored form. 2 times all of this, it's the two factors p plus 9 and 3 minus 2p. Now in the end, because everything is being multiplied, you don't even need these black parentheses. In this case, we technically have three different factors. 2, the factor p plus 9, and the factor 3 minus 2p. So this one would actually have three different factors, but if we were to multiply all of this together, each piece together would multiply to this old polynomial. And that'll conclude our second video on factoring.